in this integral I am going to use Gaussian integral. So what I will do is, here this minus 3 is constant over here, so I will try to send outside. So this is same as integral minus infinity to infinity. So this is same as e raised to minus 2x square minus 5x into e raised to minus 3 into dx. So this e raised to minus 3 I will send outside. This same as, since it is constant, e raised to minus 3 integral minus infinity to infinity e raised to minus 2x square minus 5x into dx. Now I am going to use Gaussian integral. What is Gaussian integral? Is if we have integral limit of minus infinity to infinity e raised to minus x square dx is same as square root of pi. This I am going to use it. Since I have minus x square over here, so I will try to make completing perfect square over here. Let's consider minus 2x square minus 5x is equals to, if I take minus 2 common, here x square 5 by 2 x. This sum is minus 2 x square plus twice a. So I want to get 5 by 2, so I need to write 5 by 4 plus 5 by 4 the whole square I need, but this is extra, 5 by 4 the whole square. So minus 2 from here to here, it become x plus 5 by 4 the whole square. Okay, and then if I send this to over here, then I will get plus 2 into 5 5 is 25 upon 4 4 is 16. So instead of this, I can write like this. Okay, therefore is equals to integral minus infinity to infinity. Here we have e raised to minus 3 e raised to minus 2 and then x plus 5 by 4 whole square plus 50 upon 16 into dx. What I can do is, this 50 upon 16 I can write like this, this is into e raised to 50 upon 16. Okay, since it is constant, so I can send again over here, this is e raised to 50 upon 16. Now here, if base are equal, we can add indices. 50 upon 16 minus 3 is same as e raised to 1 by 8 into this we have. Okay, so u equals to x plus 5 by 4, therefore du equals to my dx, or what limits stays same. Okay, so this is equals to e raised to 1 by 8 minus infinity to infinity e raised to minus u square into du. Okay, let's consider this. Since e is variable, so let I equals to integral minus infinity to infinity e raised to minus x square dx. Okay, and it is same as integral minus infinity to infinity e raised to minus y square dy, because x and y are all variable. Okay, so I can consider this also I. If I multiply these two, I into I will get I square is equals to, I will get double integral minus infinity to infinity I will have e raised to minus x square minus y square into dx dy. Okay, so is equals to minus infinity to infinity. If I take minus common, here x square plus y square into dx dy. There is a relation between the coordinate or Cartesian coordinate to polar coordinates. We have dx dy equals to r dr into d theta, as well as x square plus y square equals to r square. Okay, this is conversion from Cartesian to polar. Therefore I square equals to, and then limits is going from, theta will go from 0 to 2 pi. Okay, here therefore this will be 0 to 2 pi So r will be from 0 to infinity. So r will be from 0 to infinity. So e raised to this become minus r square r d theta dr. Okay. So this d theta I can send over here. D theta I am sending over here. So is equals to integration in this is we'll have only 2 pi. Okay, 2 pi integral 0 to infinity e raised to minus r square r dr. Now let's substitute this equals to u equals to minus 2r square du equals to 2 is a 4 r dr. So I will send minus 4 down. Okay, so limits will be stay same is equals to 2 pi 0 to infinity this e raised to u du upon minus 1 by 4. This equals to minus 2 pi upon 4 e raised to u. Limit is from 0 to infinity. Here will be 2 pi upon 4 0 minus 1 minus plus here 2 pi by 4 means pi by 2. Okay, this is ms by on the left hand side what we have I square. Okay, therefore I square equals to pi by 2. Therefore I equals to square root of pi by 2. Okay, now what we are doing is what we are solving only these parts. Okay, we are solving on this part. Therefore this integral equals to e raised 1 by 8 into square root of pi by 2. Okay, this is the required answer for this.